Welcome back to Arcade. We are making a Sokoban pushbox game in this series. In the last part, we added pushing the box and moving the player around. So, for example, like this, as you can see, we can move our player around the game board. Now, in the last video, we also ended by seeing this bug, which it's not doing it now, but let's see. There we go, that bug. And we can, of course, walk off the game board. So we're actually going to fix the first bug we saw and then stop the player from going out of bounds based on where these walls are. Let's get started. So let's see. Let's get a good reproduction case. That's pretty good. All right. So let's see. Why is that happening? Let's see. In this case, we're pushing up player X. So let's try. So certainly I think having player X being the top left corner could result in this hit box, this target contains that we used, the get box that using rec.contains, contains, since I'm pretty sure it tests less equals when it checks if it's inside the bounds. So if it's at the edge of the bounds, it will still be in the bounds. So we see that when we're going up, we're checking minus 32 on top. And given our tiles are 64 by 64, we should probably just always test in the middle. So in this case, let's say 32, we'll just test that that works before we change everything. Okay, 1 over, we're gonna go down, we're gonna go up. So that is better. Okay, so let's see, so that down is the case, so let's also do it for down. Push, go up, go down, go down, go up. Okay, so that looks to be part of the reason why. So we're going to do this for these other, for right and left as well. So when you're going right, so theoretically, let's just say left. That should also do it. So let's just fix left. Player Y up here, we want player Y down here. So this is going to be plus 32 to move down. And this should be the same, plus 32. It should be right. Let's see. I shouldn't push it, shouldn't push it, shouldn't push it, right? This pushes it, good. This does not. This pushes. This does not, this does not. So that looks pretty good. So that solves that problem. So now how do we solve the problem of the guy being able to walk into and through walls? So we don't want that. And, he's also moved off the grid. That's interesting. Let's fix one thing at a time. All right, so we want to keep him within the bounds of the game, which is defined by these tiles. And so those tiles are tile 100. So let's see. So our tween move, we don't need this anymore. Just delete this commented code. So our tween moves is how moving happens. And we check for a box to push. Now, let's think. So if there is a box, we are certainly pushing something. Let's do this one at a time. But if there is no box, we could be walking without pushing a box. So that could be the wall, let's say. And well, we don't actually have an X and Y here. Okay. No, we can't put it in here unless we add some more data to the tween move. But what we want to know is check for wall. So let's just make a method that checks for wall. Private, let's just say get wall at X, Y. layer. So I believe layer has a way of checking. So let's see, layer.getTile at world xy. That's what we're going to have, world xy. And that should return us a tile. So let's see. Let's look at some docs to see what a tile actually gives us. Tile class. So we're going to want to know what its index is. So its index, what am I searching for? Index. There we go. Okay. So we're going to save our layer here as part of this class. We can access it later. So private, let's call it layer for now. We want to change it to something else if we have multiple layers. Tilemaps dot tiles. We're doing a static layer. Okay, it could be null theoretically or undefined. This dot layer is that. And let's change that, So you see that VS Code gave me these little error swigglies, which we wouldn't get if we were not using TypeScript. That's why using TypeScript is also so much more awesome. It tells you errors as it analyzes the code statically, so you don't have to wait until you run it and then, oh, something bad happened. It saves you a bunch of time. Okay, so we got the layer there. Okay, back to this get wall at. So this, well, if for some reason there's no layer, we're just going to return undefined. And then this dot layer dot get tile at world xy tile, and if not tile, we're also going to return undefined, and otherwise we're going to return get wall. Maybe we should rename this. How about has wall at? So false, false. And then, so we're going to just assume right now that 100 is the index. So if tile that index is 100, then we have a wall. Okay, so now we know how to check for walls, theoretically. Let's test this. Let's test on the up. Just go up a few times, 1, 2, 3, then we should run into a wall. So let's just put this in here for now. So if this dot has wall at, and we know we're going here, we're just going to copy this for now. We'll clean this up shortly. Console.log has wall. Okay. Let's see. No wall. Wall. Oh no, where's my console? Has wall. Okay. So let's see. Const. So we're going to call this. Let's call this nx for next x. Some of you may prefer or are screaming at this because you prefer to use more descriptive variable names, and I totally think that is valid. But I think I'm probably going to end up refactoring this, so I'm not sure how much this matters right this second. Well, let's see. If has wall, we're actually going to not do any of this. Early exit may be wrong here, but just as a test. All right, I'm pressing up and I can't move, so that's good. So let's see, how should we go about this? What is the best way? So we know has wall. So if not has wall, we do this, otherwise we don't want to do it. So there's tween move. What we can do is actually move most of this logic into Tween Move. Right, so like even getting the box and all that. So let's say Tween Move doesn't take a box. Tween Move, let's just say, instead of taking a box, we're going to take an X and a Y. So we're moving 2. And we're going to get the box in Tween Move, which is this. And what we're going to do is move, get the box at there, if there is a box, okay? So that's the box logic. So let's just change some of this. So in this case, we don't need this, but we will need this. And instead of a box, we're going to give it the coordinates that we want to move to. Okay, and in this case, same thing. No longer passing in a box. And for left, same deal. No longer need the box. And then for down, same deal. No longer need the box. Okay, so let's just test that left, right, and down still work fine. Indeed. And that can't go up. Okay. Now we are going to check wall in our tween move. I'm pretty sure that should be fine. So first we're going to check that there is no wall. If there is a wall at that position, we're just not going to do it. Okay. Let's see. Undefined. N. Yeah, no, not N. Y. Okay. Can't go there. Oh. Ah. I see. Well, that's bug. Unrelated to what we're testing. Okay, can't go right. Can't go down. So the bug is basically hitting up too fast, or any key too fast. Okay, can't go up, and just test left. Okay. Brilliant. So that wall blocking code seems to work. Now let's fix this other bug we came across. So what happens is if I press right, let's say just right would be true, and then I press it again before the tween has finished, just right is still true, and it will continue. So now the question is, I don't want to tween if the player is already tweening. So in that case, here's that. Is there a way to check if a tween is running without what's existing? Without having to store the active tween, which we of course could do. There is tweening, but is tweening what? Oh, is tweening target. It seems right. Checks given effect by playing tween. Okay. So if this dot tweens, that is tweening, so this is player turn. So if the player is already being tweened, do not do another tween. So, oops, go to the game here. Yep, that seems to be right. That's a good enough fix for now. Okay, so that's that. So that works. We can push this box still. Boom. So with Sokoban, of course, once you push a colored box onto a colored circle, the level has finished, or once all the boxes has done that. So come back for the next part 5. We're going to implement that game logic of recording a win when your box is over the target.